Good morning, I'm Pierluigi Freni, Innovation Specialist and Blockchain Researcher at Link Foundation. Today, I'm presenting you our work on tokenization and blockchain tokens classification based on a morphological framework. We started from the awareness that even if blockchain has been around for more than 10 years now, on one side we have quite a clear and shared understanding and knowledge about the technical aspects of this technology, while on the others, the business and social implication of the technology are still not very clear and shared. One of the key points that was an innovation that was brought by blockchain is decentralization. In particular, thanks to the leveraging of consensus algorithm, it's possible to cut off central authorities and central guarantors that are usually entitled to provide a univocal source of truth. And so we have this first paradigmatic shift that comes from decentralizing the source of truth and cutting off centralized guarantors. It's important also to underline that the decentralization has been applied across different contexts. And so if Bitcoin was, let's say, our first example of decentralization applied in a monetary context, after it, many other applications came by and different value-based scenarios were, let's say, contaminated by decentralization. At the center of this decentralization process is tokenization. Tokenization can be defined as an encapsulation of value in tradable units of account called tokens or coins. And by expanding these encapsulation of value beyond the, let's say, economic context, I mean, there were manifold representation of value that have been partitioned and traded thanks to blockchain technologies. And we can also say that the tokenization process goes through the creation of a self-governed tokenomic system whose rules are programmed by the token issuers. In fact, once tokenized, this manifestation of values can be leveraged in the context of a system of incentives that promotes a fair wealth and power redistribution within blockchain-based ecosystems. And this brings us to another paradigmatic shift, namely from economics to tokenomics. It's important to underline the fact that this shift is based on moving from a predictive basis approach to innovation to a design basis approach. In particular, we see a shift from the passive observation of how an ecosystem reacts to a change introduced to the active design of the ecosystem constituent laws that are aimed at reaching the desired outcome through the coordination of the actors and the alignment of their reasons to act within the ecosystem. At the core of this tokenization process, there is the token itself. And the token can be defined as a socioeconomic dummy tool that promotes the coordination of actors within a regulated ecosystem. This action is coordinated towards the pursuit of what is called a network objective function through a set of incentive systems. Since a token is a dummy tool, its nature isn't defined in itself, but it relates to what the token represents. And analyzing what this representation of value is connected to, the concept of trust emerge really, always. So in the end, it's possible to define a token as a quantifiable representation of decentralized and disintermediated trust. Given the wide nature and applications of tokens in manifold ecosystem, the need for tokens classification has emerged as primary, and this is the major goal of this work is to define and propose a comprehensive approach to token classifications that can map accurately all the different possibilities of value representation that tokens can bring by. To do so, we have chosen the general morphological analysis as a methodology. In particular, this methodology has been developed to describe and characterize non-quantifiable and multidimensional properties problem complexes. And this methodology can be used also to identify recurrent patterns and build inference models that are non-quantitative. This methodology has been applied following these 3 steps. So at first, we define the dimensions of the problem that are the parameters along which each token can be mapped. Then we define a spectrum of values. So for each dimension, all alternative possibilities that that dimension can assume are mapped. And finally, the morphological field describing the token is generated, including all the possible combinations of value along all the dimensions considered. To start from, we analyzed the literature. In fact, the effort for defining a classification framework for tokens has been quite extensive. And since classifications proposed by different authors in the literature are themselves very diverse and different, to make them comparable, we applied the GMA methodology also to them to make them comparable. And this analysis was intended to provide a first basis for the definition of our framework and to identify gaps, uncovered properties, and also redundant dimensions to be discarded. And as we see in this table, there have been different approaches, especially while the number of dimensions describes in a way the multiple points of view that authors took into describing tokens. The number of values for each dimension describes how deep each of them went into description of each dimension. And the number of all possible configurations varies a lot, and we see that it scales much faster with the number of dimensions. This means that aiming for a comprehensive framework, we must look for a higher number of dimensions. That means that we must aim at looking to the tokens from as many points of view as possible. To build our morphological framework, we grouped all the dimensions that we found in the different classification frameworks into 5 domains, namely technical domains regarding technical aspects of the token, behavior domain that includes all the behaviors that a token can have, inherent value domain that relates to the economic value that is represented by the token, The coordination domain, that is a synthesis of how the characteristics of the token induce behaviors into the actors, coordinating their actions, and pseudo archetypes, that are all those dimensions that combine different characteristics and in a way anticipate archetypes. The results of this work is this morphological framework, in which we discarded all the dimensions belonging to the pseudo archetypes, because they went a step further, so they are kind of misleading, and we retained the other 4 domains and grouped the dimensions of them. The proposed framework is characterized by 16 dimensions and an overall number of more than 41 million possible configurations. So it's, let's say, very, very extensive and can map tokens along a wide range of characteristics. This is, let's say, an initial step for us, because in the future we are iterate on this framework. In particular, we're gonna check that against actual tokens. So applying the framework to classifying selected numbers of diverse tokens, we will revise eventually the dimensions and values for each dimensions. In particular, specific focus will be given to incentive systems and how those are conveyed by tokens characteristics. This further analysis will lead us to identify recurrent patterns and group similar tokens into token archetypes. Finally, the organization in a hierarchical structure of these token archetypes will generate a proposal for a comprehensive token taxonomy. This project has been carried on within the context of the Helios project, a EU-funded project about social media and decentralized social media and blockchain, and is part of an extensive research activity of Over the Block, that is a permanent observatory on blockchain technology powered by Links Foundation. Thank you.